configuring a new home online, clicking a button, and having it delivered fully finished, locking perfectly onto your foundation. That level of speed feels impossible right now. Across the globe, housing demand is massively outpacing supply, driving prices out of reach for millions of people. The root of this shortage comes down to how we build. Traditional construction is essentially a custom manufacturing process performed entirely outside in the elements. Every project relies on a fragmented web of specialized contractors and fluctuating supply chains. If a sudden rainstorm hits or a specific framing crew is short-staffed, the site sits idle. We still build suburban neighborhoods the exact same way we did a century ago, nail by nail, stick by stick, relying on manual labor. From an engineering perspective, this creates a cascading bottleneck. Because work must happen in a strict sequence. A delay from one early contractor pushes the entire timeline backward for the electricians, plumbers, and inspectors waiting in line. We have an exponentially growing population needing shelter, and we are trying to solve it with an artisanal, unscalable production method. To scale up volume, the construction site has to move indoors. It requires a highly controlled, weatherproof environment. 100 years ago, automobiles were built one at a time by bespoke craftsmen, making them incredibly expensive. It took a standardized, continuous process to finally make vehicles accessible to the public. We can apply that exact logic to housing. Through a process called industrialized construction, a complex architectural floor plan is broken down into repeatable subassemblies, like structural wall panels, pre-wired electrical grids, and fully finished plumbing cores. Instead of treating a house as a unique local project, it becomes a high-volume product, built sequentially by dedicated teams moving down a line. Today, that line is highly automated. Robotic systems handle the heavy lifting, measuring, cutting, and fastening materials with tireless precision. Treating human shelter as a manufactured product on a continuous line provides the repeatable output necessary for large-scale production. Before a single physical blade cuts into a piece of wood, software creates a perfect digital twin of the entire house. This system simulates the build, optimizing the schedule and programming the machines. Running dozens of automated systems and using artificial intelligence to manage thousands of moving parts requires an immense amount of local processing power, known as edge inference compute. This demand for computing power is fueling the construction of massive semiconductor facilities, like the Terafab project in Texas. These sites are being built to produce the next generation of specialized AI chips required for large-scale robotics and factory automation. When you connect advanced compute to physical robotics indoors, the immediate benefit is speed. A factory operates year-round, completely immune to snow, rain, and extreme heat. Next is quality. Every cut and fastener is verified by sensors, eliminating the inconsistencies that naturally occur when humans are forced to work outdoors under pressure. Because the process is entirely mapped out in advance, the factory orders exact material quantities, slashing raw material waste. Finished modules can also arrive pre-fitted with highly efficient, standardized energy systems. Combining advanced computing with industrial automation introduces predictability and optimization to a process that has historically been defined by environmental variables. Building this system is expensive. Constructing an advanced manufacturing facility capable of pumping out thousands of homes requires billions of dollars in upfront capital before a single unit is sold. Then there is the physical reality of moving a house. Transporting a multi-ton, fully finished module requires special permits, wide-load escorts, and careful route planning to navigate highway overpasses safely. Once it arrives, developers have to navigate highly decentralized local zoning codes that frequently conflict with standardized, factory-built blueprints. And then there is the historical stigma. For decades, the word prefab carried a negative connotation, bringing to mind the repetitive, low-quality temporary structures hastily built in the mid-20th century. Today's modular architecture looks nothing like those older structures. Advanced digital design allows builders to easily alter floor plans, finishes, and layouts, creating infinite architectural variety using the exact same underlying structural components. We are moving toward a model where the components for high-end, diverse neighborhoods are manufactured in a matter of days, and then quietly assembled on site in a matter of weeks.
Achieving that level of manufacturing velocity drops the per-unit cost, which is the necessary step to making high-quality shelter affordable for a growing global population. Just as the assembly lines scaled human transportation, the factory floor allows high-quality housing to be produced at the volume required to meet global demand. The future of construction starts indoors.